Thank you, that's much better. Okay, well, since we've talked about our three-dimensional coordinate system, one of the things we would do in two-dimensional coordinates is talk about what are called the conic sections and analytical geometry. Well, good gracious, now we've got a third dimension. So let's start talking about the three-dimensional version of a circle. Is a sphere. And it's a set of points in R cubed, such that each point on the sphere is a fixed distance, r, meaning the radius, from a point called the center. And we'll call that x sub 0, y sub 0, z sub 0. And if you think back to the definition of a circle, just pop off the z sub 0 and we have it, right? That would be, I guess, r squared. So this is the three-dimensional version of a circle. It's called a sphere. So the equation, which would come from the distance formula, x is a variable point, or x, y, z is a variable point on the surface of the sphere, and x0, y0, z0 is the center of the sphere. And so the square root of that distance is equal to r, the radius of the sphere. So square both sides, and we have this nice formula, which is really easy to derive if you think about it. It's just like deriving the equation of a circle. So there is a sphere. How about that? So this is interesting. We're still doing some analytical geometry here. The point that is the midpoint of the segment joining x1, y1, z1 and x2, y2, z2 is similar to the midpoint in two-dimensional space, because what you do, you just find the average of the x coordinates, the average of the y coordinates, and the average of the z coordinates, and that's how you find the midpoint. So we're getting into some quick and easy analytical geometry, and you'll notice the similarity between this and analytical geometry that you've learned in two-dimensional space. Okay. Now, find the equation of a sphere that has 3, -5, 4, and 9, 5, -4 as endpoints of a diameter. Oh my! Suddenly, we have a not-so-simple problem here. Let me give you a little think time on that before we proceed, okay? We want the equation of the sphere that has 3, -5, 4, and 9, 5, -4 as endpoints of a diameter. Alright, so let's attack this thing. First thing we would want to do is find, I mean really, we can find the equation of the sphere, right? If we only had the center, x0, y0, z0, and the radius. Okay, so let's do that. I don't know which one you'd want to do first, but the center of the sphere, since this is the diameter of the sphere, the center would be the midpoint of this diameter. And so if we added 9 and 3, we get 12, divided by 2, we get 6. We'd have adding 5 and -5 is 0, divided by 2 is still 0, and adding 4 and -4 is 0, still divided by 2 still gets 0. So 6, 0, 0 is the center of this sphere. Now, when we want to find the radius, we're going to have to find what half of the diameter is, and in order to find the diameter, we need to find the distance between these 2 points. So we would set up square root of 9 minus 3, that's 6 squared, plus 5 minus -5, that's 10 squared, so that's 136 so far, and then 4 minus -4 is like 8 squared, so let me think, what do I have, 136 and now 64, so that's 200. The diameter of the sphere is the square root of 200. Well, how can we simplify that? That's 2 times the square root of 100, that's 10 square root of 2. That's the diameter. However, we don't want the diameter, we want the radius, and that's half of that, so 5 square root of 2. So we got the center, 6, 0, 0, the radius, 5 square root of 2, and here's where that all came, right? And you can check those calculations if you want. So here's the equation of that sphere. x minus 6 squared plus y minus 0 squared plus z minus 0 squared equals 5 squared to 2 squared. I guess we could simplify all this if you wanted to make that x squared minus 12x plus 36 plus y squared plus z squared equals 50. So that should be pretty straightforward.